8th grade functions, linear functions. This gives us a table dealing with the weight of a tiger. The x values measure the age, and age is measured in terms of weeks. The y value measures the weight, and of course it's measured in pounds. So let's interpret this table. If a tiger is 0 weeks old, newborn, how many pounds does it weigh? 3. If a tiger is 1 week old, it weighs 5 pounds. If a tiger is 2 weeks old, it weighs 7 pounds. If a tiger is 3 weeks old, it weighs 9 pounds. If a tiger is 4 weeks old, it weighs 11 pounds. I would like to know if this data, or these points, if plotted on a Cartesian plane, will it form a line? Well, let's look at it real quickly. The lowest x term I got is 0. And since all of my values are positive, I only need quadrant 1. Okay? 1, 2, 3, 4, 5, 6. So I'm labeling my y-axis. That's my x-axis. And again, you don't see the other 3 quadrants because the values are all positive. 1, 2, 3, 4. What points do you see? My first point is 0, 3. Then 1, 5. Then 2, 7. Then 3, 9. Then 4, 11. So if I plot 0, 3, it'd be right there. If I plotted 1, 5, here's the 1 on the x value, go up to the 5. 2, 7. 3, 9. And of course I didn't carry my y-axis up that far, but you get the general idea. Does this form a line? Yes. Is this a positive linear function or a negative linear function? Well, I don't know, Mr. Gray. I don't know how to tell. When I look from left to right, what happens to the line? Is it rising or is it falling? Well, it's rising, so this has a this is a positive linear function, or it has a positive slope, which we'll learn more about in our next lesson. But what I need to figure out is which equation, which linear function down here represents this data. I use substitution to figure out which equation best represents the data in this chart. So I'm going to start with equation A. W equals 2A plus 3. And this is the one for A. I take my 5 points, 0, 3, 1, 5, 2, 7, 3, 9, 4, 11, and see if the left side equals the right by substituting the appropriate values in for the appropriate variables. W stands for weight. A stands for age. The first point I see is 0, 3, so I'm going to use the 0 and the 3 and place it into my equation or substitute. 0 is our A, so it goes here. W is our 3. 2 times 0, 0 plus 3. Does 3 equal 0 plus 3? Sounds good. Does 3 equal 3? Yes. So this equation works for just this point. Let's check the other one. And each equation must accept every single point in the chart for that to be the correct equation. So yes, it requires you to do some work. But as you become fluent in this skill, you'll be able to look at them and tell, watch. You won't have to do that work. You'll be able to look at it and do it in your head. Okay? Let's use 1, 5. 1 goes in for A. What goes in for W? 5. 2 times 1 is 2 plus 3. Does 2 plus 3 equals 5? Yes. Yes. So that point works. Let's try the other 3. Now, if every point is a solution to this equation, will I have to check the other 3? No. Okay? It worked for this one. Unless your problem told you that it could have multiple answers, which is highly unlikely if it's multiple choice. Okay? Let's use 2, 7. 2 stands for the A, and then W is the 7. 2 times 2 is 4, plus 3. Does 7 equals 4 plus 3? Yep, so that one works. Let's try the 3 and the 9. The 3 goes in for the A, and all I'm doing is substitution, or replacing the variable with the appointed number. And then 9. 2 times 3 is 6, plus 3. Does 9 equal 6 plus 3?
Yes.
Yes, so that one works. Looks like we found the equation on the first go-round. That rarely happens. Okay? 11 equals 2 times 4 plus 3. 11 equals 8 plus, does 8 plus 3 equal 11?
Yes.
Yeah.
Yes.
So that one works too. So what's our answer? A. How did I find it? I had to take each point from my chart. Sometimes it'll give you a table. Sometimes it'll give you a list. Sometimes it'll give you a graph. And you have to pull the points off of it. Either way, you take the points in the data set, plug it into the linear functions that it gives you. See if the left side equals the right in every situation. And then select your answer. Very good.